The topic that I'm going to talk about today is standard deviation, and the purpose of standard deviation is to take something that has a mean and expand upon it so that you can compare. Just having a mean just tells you that something is average, and it really doesn't tell you how average it is or how far above average or below average you are. But once we throw something in there called a standard deviation, it really starts to give some meaning. And it's exactly what it is. The word is deviation, which means how far it varies from what we call the norm or whatever. And I'm going to go through some examples of 3 of them with bowling scores and kind of give you an idea how this works and how it's derived. And I'll show you how to compute it by hand, kind of by hand, using Excel to do my computations for me. And then I'll show you how Excel can do it. And there are also internet sites that you could go to calculate standard deviations as well. And let's start with some bowling scores. As I said, I'll show you how to calculate standard deviation using both Excel with just a simple command and actually doing the computation longhand with a calculator, calculating with Excel. Now let's take a set of bowling scores, and as you can see on the left here, I've listed 10 bowling scores, and they're all the same, meaning there isn't a whole lot of variation here. And as you look at them, you can easily see that every score is the same, so we wouldn't expect much of a standard deviation. And I'll show you how to calculate this on Excel. Using the commands on Excel, what I can do is equals STDEV, and then we're going to go from cell A2 down to cell A11, and you can see that it computes to a standard deviation of 0. I don't know if you can read that very well. I'll increase the font there so we can see that, but it is 0. Now, that formula is locked in there, so if I were to change any of these numbers, meaning that they weren't exactly the same, you can see that we start to get a little bit different value for standard deviation. And it changes as we go. So as we get numbers that are varying from the norm, we're going to start getting larger and larger standard deviations. Now what I've done here is I've also put a set in here with some different values, which again 10 different values, but they're a little bit further away from 180. You notice it goes all the way from 171 up to 189, so it's not a big range, but they're not perfectly the same. So what I'll do is I'll find the standard deviation of these. So we'll go with equals STDEV, and again I'm going to go from A1, A2 to A11. And now you can see that my standard deviation value, and I don't know why I put it way over there, but I did, is a little bit higher. It's rounded off to about 6. Now, taking a third set of numbers, and in this particular case, the range is quite a bit higher. You can see the scores go all the way from 153, I believe, all the way up to 228. So there's a bigger variance with these scores. And as I do the standard deviation of these, and again, equals STDEV from A2 to A11, you can see that we'll get a value of 29.402. So it has quite a bit higher of a standard deviation. Now at this point, that probably doesn't mean a whole lot to you. All it is a number. And I'm also going to show you how to calculate this in a moment. But what a standard deviation does, and I'm just going to pull up a PowerPoint slide here and look at these a little bit individually, is it's part of a bell curve. Now if you were to take all the bowling scores in the league, and let's say there were hundreds of them, they would probably form a mean somewhere in the middle because it is a measure of central tendency, and then it would form this bell curve that comes out. And you can see that on the bell curve, if we were to locate standard deviations in both directions, and I'll show you this a little bit more with numbers later, but let's take our bowling score, and let's say our mean was 180, and I were to then go one standard deviation in this direction, that would be 186, and one standard deviation back would be 174. What it would tell us is that 68% of the scores would be in that range between 174 and 186. And remember that the numbers are what dictate the standard deviation. It's the numbers that you put in that actually tell this figure. It's not to say that we have a bowling league with 150 people that we're going to get a standard deviation of 6. It's the scores that determine it. And that was shown in the example that I did previously. Now, if we were to go 2 standard deviations from the mean, that would put us 6 plus 6, or 12 above, at 192, and 6 plus 6 from 180 in the other direction of 168. We would find that within 2 standard deviations of the mean would be 95% of the data. And that's very important because later we're going to talk about 95% confidence levels. And the 95% confidence level means within 2 standard deviations of the mean. It goes from 2 down to 2 up. And then, of course, the 3 standard deviations from the mean go quite a bit in that direction. That's almost all of the data. It says 99% here, but it's actually 99.7% of the data is within 3 standard deviations of the mean. When you talk about outliers, your outliers generally will be outside of 2 standard deviations in any direction. Okay, again, your numbers determine the standard deviation. I'm going to look at the formula here for calculating standard deviation. And you'll see that it's a fairly complex formula, but I'm going to break it down for you, and we'll work on this a little bit. It's not really that bad. The symbols that we use, the first symbol is the Greek letter, it's delta, which represents standard deviation. You can see that right there. And then the formula is the square root of x minus mu, mu being the mean. And then we take the sum of all that, square it, divide by n minus 1, and take the square root of all that. So I think if I can go back to my Excel program and do an example here, we'll get a little better idea how this works. So let's go to the bowling scores that I had in set 1. And I'm going to put them back to what they were. We're going to go back to 180 on all of these. And just to show you how we get this. What I'm going to do here is I'm going to take the difference between the mean and each individual score. So what I'm going to do is I'm going to take 180, which is the mean, and I'm going to subtract from it this number right here. Okay? Oops, I forgot my equal sign. Okay. And you can see that that gives me a value of 180. I goofed up. I got to start over. Okay. What I'm going to do is I'm going to take this particular score right here, and I'm going to subtract it with the mean, and you can see I get a difference of 0, and I'm going to copy this all the way down. And that gives me a bunch of zeros. In other words, there is no difference between the mean and each score. Now, if I add those up, obviously, I'm going to get 0. And if I divide that by n minus 1, or 9, because there were 10 scores, you can see that I'd get 0. And if I take the square root of 0, I get 0, which is the standard deviation that we got when we did the computation before. Now, it'll make a little bit more sense when I do set 2. In set 2, where I take all the bowling scores here, in my first column, what I'm going to do is I'm going to take the score and subtract it from 180, or subtract 180 from it. And you can see I get a value of 6. And as I copy that down, I should get another 6 there, negative 6, a 5, a negative 5, a 2, negative 2, a negative 9, a 9, a negative 3, and a 7. All right? Now, the next step in the formula is that I need to square each of these numbers. And the reason you square them is because it gives you a positive value when you square them. So I'm just going to take this number times this number again. And what it gives me is 36. So as I'm going down, you can see that the squares, 36, 25, 25, 4, 4, 81, 81, 9, 9, are going to give me some values. And now what I want to do is I want to add up all these numbers, because that was the next step. It was the sum of these differences squared. So as I add those up using my sigma, you can see that I get a value of 310. The next step in the formula was to take the 310 and divide it by 9, and it gives me, oops, divided by 9, if I could see, I could do this. And I get 34.44, and the last step is to take the square root of 34.44, which is about 6. And I think if we had not rounded this off, it would show up a little bit better, but it gives us our standard deviation of 6. So you can see that in the second example, we have some differences between the 180 and the scores. So it does give us a standard deviation. All right, now I'll go to sheet 3 here, where the scores were quite a bit different. And I'm going to do the same thing. I'm going to take this score right here, and I'm going to subtract 180 from it. And you can see I get a value, and then I'll copy those down. This Excel is a pretty neat thing, by the way. So what that gives me is the difference between each score, high or low. My next step will then be to square all of these numbers. And you can see now that my numbers are quite a bit higher than what they were in the past. And they're considerably, I mean, look at the clout that that 228 has on that data right there. And again, the 184 is very little clout. But when I sum up these numbers, I now get a fairly large value. And I'll divide that value by 9. And if I take the square root of 865, it would come out to my standard deviation of 29.40. So you can see how the difference from the mean is what really determines the standard deviation. The closer they are to a norm, the less standard deviation you're going to have, and as the numbers start spreading and spreading and spreading, you're going to see more standard deviation. All right, here I have that old 68, 95, 99.7 curve with standard deviations in it. And when the standard deviations are real close, your curve is going to look something like this. And as your standard deviations start spreading out, your curve is going to get wider and wider and wider, which is just logical. And if you have really large standard deviations, your curve could almost, start looking a little bit flatter and flatter. And it's just logical that it looks that way. So there's a really drawn-out curve with large standard deviations in it. All right, going back to the PowerPoint here and remembering where these numbers came from, that we took the sum of the number, each number minus the mean, squared, and then we divided by n minus 1, which in this case we had 10 numbers, so we took 9 and then took the square root of it. It gives us the standard deviation. All right. And here's our bowling scores, all the same. You can see that the standard deviation was 0. The second set where they were a little bit different, we had a standard deviation of about 5.88. And the larger set where we came up with the standard deviation of 29.40. What I've put on here is one of the most common uses of standard deviation, which is IQ. And you can see that the mean IQ, and it may have changed a little bit nowadays, but was 100, and the standard deviation of 16. So you can see by looking at the curve that between 84 and 116 is pretty normal, meaning that 68% of the population will lie within this range. If we go 2 standard deviations out, you can see that we're between 68 and 132. That means that 95% of our population is between an IQ of 68 and 132. And if we go 3 standard deviations, we're between 52 and 148. 99.7% of our population has IQs between 58 and 148, or 52 and 148. So it's distributed very equally. It's probably one of the classic examples of standard deviation. And you can kind of tell where you are if you know your IQ. What I highly recommend you do is take an IQ test or talk to your guidance counselor at school and find out what your IQ is, and you can kind of see where you stand on the curve with relation to other people. In the next section, we'll be talking about things called z-values. And what a z-value is a standard deviation that is not an integral value. If you notice, this chart goes out 1, 2, and 3 standard deviations in each direction. What if you have an IQ of 120? That would be somewhere between 1 and 2 standard deviations. And what you can do is take your 120 and convert it to a standard deviation value and go to a chart or some kind of a program, and it'll tell you what percent you are on the curve, so that if you were right here at 120, you could find out exactly what percent of the population would be below you and what percent would be above you. Because keep in mind that there's always 100% of the population under any given curve. So IQ is a very good example of using standard deviation. The next example I would like to give you is ACT scores, and this is an old one, but it shows the standard deviations. And this particular person that did this assignment had an ACT score of 19. And what they did was they figured out what percent are below and above them by using the z-values. So this is kind of an introduction to what you'll be doing in the next chapter. So in 2000, the mean ACT score was 20.9. And the standard deviation was 4.6. So you can see what happens when you add to it and subtract to it and go out 1, 2, and 3 standard deviations from the mean. We can see that anything above 30.1 would be an outlier in the positive direction, and anything below 11.7 would be an outlier in the negative direction. Again, talking about the 95% that occurs between -2 and +2 standard deviations. So I showed you 2 ways to find the standard deviation. One is with Excel by just putting in the formula equals STDEV, and then the cells that you're finding the standard deviation of. So you could have hundreds of numbers and calculate the standard deviations. The second way is the long way, where we use the formula. Standard deviation is equal to, again, the square root of the sum of all those things divided by the one less than the number. And the third way that you can do this is there are tons of internet programs out there. If you just do a search for standard deviation calculation, it'll bring you to something where you plug in the numbers and press a little button and it'll tell you the standard deviation. But again, the big value of standard deviation is that once you have a chart, you can compare by knowing how far you are from the norm and recognizing that 68% of the population of any sample will always be between 1 standard deviation, 95% between 2. So that's how standard deviation works, and from there we'll worry about z-values and comparing a little bit more accurately than what this will do.